Hello and welcome. I am Dr. Pauline Fu. In this video, I will present probability rules. At the end of this video, you will be able to apply the rules of probability, use empirical method to calculate probability, use classical method to calculate and interpret probability, and also use Excel to simulate data based on probability. Finally, you will recognize and interpret subjective probability. And plus, I will also talk about addition rule for probability, and complement event, complement probability, okay? So what is a probability? A probability is a measure of likelihood of a random phenomena or chance occurring. For example, we can use Excel to simulate flipping a coin 100 times. We all know when we flip a coin, we either get a head or a tail. We don't know if we are for sure to get a head or for sure to get a head. That's why it is a random phenomenon. So now I'm going to use Excel to flip a coin 100 times. So I will use Excel random number generator, rand between. When we flip a coin, we either get a head or tail. So let's say 0 is head, 1 is tail. Okay. So, and I'm flipping this 100 times. So this is the simulation I get. Flip a coin 100 times. Okay. If I repeat this procedure, we get the law of large numbers. It said, as number of repetitions of a probability experiment increases, the proportion with which a certain outcome is observed gets closer to the probability of the outcome. So if I, instead of flip 100 times, I flip 1,000 times or 10,000 times, and then I count how many are heads, how many are tails. I will roughly get half. Okay, 50% of the tails and 50% of the heads. That is the law of large numbers. Next, we are going to introduce some terminology associated with the probability. The experiment is a process that can be repeated in which the results are uncertain. When we flip a coin, that is an experiment. Sample space, capital letter S, of a probability experiment is the collection of all possible outcomes. In our example, flipping a coin, sample space S, we either get a tail or we get a head. That is my sample space. An event of any collection of outcomes from a probability experiment. An event may consist of one outcome or more than one outcome. We will denote events with one outcome, sometimes called simple event, EI. In general, events are denoted using capital letters such as capital E. Now let's look at an example. identify events and sample space of a probability experiment. And this experiment is a couple having 2 children. Question 1. Identify the outcomes of the probability experiment. So when a couple give birth to 2 children, the outcome could be boy, boy. So that is one outcome, E1. The outcome could be boy, girl. Okay. Another outcome, E2. And could be girl, boy. Okay. Outcome, E3. Could be girl, girl. Outcome, E4. So the outcomes are those E1, E2, E3, E4. Question 2, determine the sample space. So the sample space use capital letter S. You use the curly bracket, opening bracket, closing bracket, represent sample space, and inside this curly bracket, you use round bracket, list all the outcomes identified in question A. Question 3, define event. E is have 1 boy, have 1 boy. So out of those events, which one have 1 boy? So this one have 1 boy, and this one have 1 boy. So the answer is here. Okay. The general rule for probability has 2. The first one, any probability must be between 0 and 1. Remember what is capital E? E represents event. PE represents the probability of event E. Any probability must be between 0 and 1. When a probability equal to 0, that is impossible event. Impossible event. For example, the sun comes from the west. We know that is impossible event. So the probability of the sun comes from the west is 0. On the other hand, if the probability equal to 1, we call that event is a certainty. Okay, so we all die at the end of the day. That is a certainty. Okay, death is a certainty. Okay. The second rule, the sum of probabilities of all outcomes must equal to 1. So if you have sample space, the outcome E1, E2, En, the probability of each event add together equal to 1. So next example, we are going to apply the rules of probability. This example is about chocolate candies. Suppose we have a bag of chocolates have different colors. We have brown, yellow, red, blue, orange, and green. And the probability of selecting a chocolate having color brown 0.12. The probability of pick a chocolate that has yellow color 0.15, etc. The question asks you, verify this is a probability model. A probability model must satisfy 2 conditions. 1, the probability between 0 and 1. The second, all the probability added together are used the sigma, must equal to 1. So let's examine the first rule. Each probability must be between 0 and 1. If you see all these numbers, they're all between 0 and 1. Second rule, if you add all these numbers together, you get 1. Okay, so that's why this table represents a probability model. Now let's introduce the empirical method. Okay. The probability of an event E is approximately the number of times event E is observed, divided by number of repetitions of the experiment. So use the formula. The probability of E equal to the relative frequency of E, okay, approximately equal to relative frequency of E. And remember, how do you calculate frequency? You use relative frequency. You use frequency divided by total number. All right, let's look at this example. Pass the Pigs is a Moulton Bradley game in which pigs are used as dice. Points are earned based on the way the pig lands. There are 6 possible outcomes when one pig is tossed. A class of 52 students rolled pigs 3,939 times. The number of times each outcome occurred is recorded in the table here. Okay. So the first column is the outcome when pigs are landing. Okay. The second column represents how many times in this landing position. What we are asked to do, there are 3 questions here. Use the rules of the experiment to build a probability model for the way the pig lands. The question asks you to build a probability model. That is the question. And how do we build a probability model? Remember, the model needs to satisfy 2 criteria. One, all the probability added together is 1. The other condition is each probability is between 0 and 1. Okay, so how do we build this table? Okay, using this example. Okay, to do that, we need to add all these numbers together. If you add all the numbers together, okay, total you get, I use sigma. Okay. The total number is 3,939. This number actually is given. It is here, see, 3,939. But just on safe side, you can verify. Add all these frequencies together, you get 3,939. And then we need to calculate relative frequency of the first landing position, side with no dot. So use 1,344 divided by 3,939. You get 0.341. Okay, so similarly, you can get the position for side with dot, 0.329. How did you get this number? You use 1,294 divided by 3,939. 1,294 divided by 3,939. Okay. So keep on going, you get all the relative frequency. Okay. And then you check each number between 0 and 1, yes, each number between 0 and 1. And then you add all the number together, do you get 1? Yes, add all these numbers together, add them all, you get 1. So this is a probability distribution model. Okay, so we finished question A, okay, probability model. Question B, estimate the probability that a throwing pig lands on the side with dot. Side with dot. Calculate this probability, side with dot. Okay. So the probability of side with dot is here, this number here, 0.329. Okay. That means in 1,000 throws of the pig, we would expect about 329 to land on a side with dot. That is the interpretation. Okay. And question C. Would it be unusual to throw a leaning roller? Okay, so we need to answer two questions. One, what is the probability of a leaning ruler? So it is 32 divided by 3,939. Okay, and we get this probability, 0.009. Okay, so that means we would expect in 1,000 throws of a pig to obtain leaning ruler. That in 1,000 throws, you only have 8 times. So it would be unusual. All right. So this one, it is just a statement saying a classical method of computing probabilities requires equally likely outcomes. An experiment is said to have equally likely outcomes when each simple event has the same probability of occurring. For example, if you flip a coin, the probability of head is 0.5, the probability of tail 0.5. Each outcome is equally likely outcome. So now we are going to introduce compute probability using classical method. Okay. If an experiment has n equally likely outcomes, and if the number of ways that an event E can occur is m, then the probability of E denoted by PE is use this formula. Okay, number of ways that event occur is m, number of ways. Total number of outcomes is n. The ratio is the probability of PE. So if S represents sample space, okay, and this NE represents number of outcomes of event E. NS represents number of outcomes in sample space. So probability of E equal to NE divided NS. It is the same as the previous formula, M over N. Now let's look at an example. Using classical method to calculate probability for this example. Suppose a fun-sized bag of M&M's contains 9 brown candies, 6 yellow candies, 7 red candies, 4 orange candies, 2 blue candies, and 2 green candies. Suppose that a candy is randomly selected. Okay. Question A, what is the probability that it is yellow? When you randomly pick a candy from a bag, what is the probability that candy is yellow? Okay, so to answer this question, we need to calculate what is the total number of candies. Okay, based on the description here, if you add 9 plus 6 plus 7 plus 4 plus 2 plus 2, and you get 30, total 30 candies. Okay, the probability of yellow equal to how many yellow? 6. So 6 divided by 30. Okay. If we want to use the notation, NS is 30. Okay, number of events in sample is 30. And question B, what is the probability that it is blue? So how many blue? Blue is 2. So you use 2 divided by 30. 2 divided by 30. Okay. That is for blue. Okay. And question C, comment on the likelihood of the candy being in yellow versus blue. Okay. So we see yellow is 3 times as likely as selecting a blue. So selecting a yellow is 3 times as likely as selecting blue because, see, the yellow is 6 over 30, blue is 2 over 30. So yellow is 6 times of blue. No, 3 times of blue. Okay. So 3 times. Okay. So this one is a simulation using Excel. Use Excel to simulate throwing a 6-side die 100 times. Approximate the probability of rolling a 4. How does this compare to the classical probability? Repeat the exercise for 1,000 times. Okay. So let's do the classical probability first. If you throw in a die, okay, remember a die have 6 sides, okay, 1, 2, 3, 4, 5, 6. This is a die. It has 6 sides. Okay, each side we label 1, 2, 3, 4, 5, 6. So what is the probability of say number 1? When you throw a die, you see number 1 on the top. What is that probability? 1 over 6. That is the classical method. Okay. Similarly, the probability of seeing number 2 on the top, 1 over 6, because there is only one number 2 on the die. And the probability of seeing number 3, 1 over 6. Okay. the probability of seeing number 4, 1/6. The probability of seeing number 5, 1/6. The probability of seeing number 6, 1/6. So this is the classical probability, okay? So this is random variable x. X could be 1, 2, 3, 4, 5, 6, any one of them. And this is the probability of x. And this table actually is a probability distribution table because it satisfies two conditions. One, each number between 0 and 1, second condition. If you add all these numbers together, you get 1, okay? So we get the classical probability. Answer the question. If you roll a die, the probability of rolling a 4 is 1/6. See here, the probability roll number 4 is 1/6. That is the classical approach. Okay, so now let's use Excel to do it. So when you throw a die, you get number between any number between 1 to 6. Okay, 1 to 6. And you throw the die 100 times. This is 100 times. Okay, and then you need to count how many number 4 here. You don't want to count one by one, okay? You want to use formula. The formula is equal count, count if, okay? So I'm going to count from B2, no, B1 to B100, criteria 4, okay? I want to count how many 4 from B1 to B100. There are 22 4. And then the probability of 4 is equal to 22 divided by 100. Okay. And this number is 0.22. It is close to 1/6. If you do the, what is 1/6? It is 0.66. They are different because you do 100 times. If you do 1,000 times, this number will approach to 0.66. So let's continue, do 1,000 times, okay? So I'm going to continue this, I will maybe delete this one. I'll continue to copy down the formula until I see 1,000, okay? Continue, oops, just want to drag it down. Fail handle, drag it down. The mouse does not working very well. Okay, good. Keep on going, going. Okay, I need 1,000. Sometimes my mouse does not work well. Okay, going, go. Okay. Okay. Keep on going. Oh, there's okay, great. This time it's going. I need to say 1,000 times. All right. Almost there. All right. 1,000 times is here. All right. And then, so I roll a die 1,000 times. I want to count how many number 4. So I will use count if from B1 to B1000. I want to count number 4. Okay, how many? 184. And then the probability of 4 is 100. It is actually this number divided by 1000. So 0.128. And this number, number 4, equal to, so this number close to 1/6. Okay, see? Okay, this number closer to 1/6. If you repeat this 10,000 times, you may get it very, very close. Okay. So that is the simulation part. Okay. So far, we did the classical method, we did empirical method. We also use Excel to simulate the empirical method and use classical method to verify. Next, let's talk about subjective probability. It is an outcome that on the basis of personal judgment. For example, tonight, there is going to be a thunderstorm. The chance is 70%. Okay, so that is my personal judgment. That is subjective probability. Okay. Another example would be an economics predicting there is a 20% chance of recession next year. That is also a subjective probability. So let's look at this example. Okay. Remember, when you calculate the probability, there are 3 methods: empirical method, classical method, or subjective method. Let's look at this example. In his fall 1998 article in Chance magazine, a statistician reads the spot page, page 17 to 21, how Stern investigated the probabilities that a particular horse will win a race. He reports that these probabilities are based on the amount of money bet on each horse. When a probability is given that a particular horse will win a race, is this empirical, classical, or subjective probability? The answer is subjective, because it is based on people's judgment, people's opinion, people's feeling. Okay. All right. So far we talked about probability rules and 3 different methods for calculating probability. Next, we are going to talk about addition rule and complement event, complement probability. So let's explain some terminology first. Move my table a little bit. 2 events are disjoint if they have no outcomes in common. Another name for disjoint is mutually exclusive events. For example, when you throw in a coin, okay, you see either tail or head. Those 2 events are disjoint. Those 2 events are mutually exclusive. Oops. And the next terminology is the Venn diagram. Okay. In Venn diagram, we use this rectangular. This is a rectangular to represent sample space, and we use the circle represent events. And this example is about we randomly select a chip from a bag where each chip in bag is labeled 0, 1, 2 until 9. Okay. And we want to use capital letter E represent the event that we see 0, 1, 2. And the letter F represent we see the number 8, 9. And the question asks you, what is the probability of event E? Event E. Event E has 3 numbers. So, and how many total numbers? 10. From 0 to 9, there are 10. So the probability of event E is 0.3. Similarly, the probability of F. How many labels in F? 2. Okay. How many total numbers? 10. So the probability for F 0.2. And next, let's calculate the probability of E or F. Okay, E or F. There are 5 numbers here. And the total number is 10. So the probability 5 over 10, 0.5. And it happened to be probability of E plus probability of F equal to 0.5. Because we know event E and event F are disjoint event or mutually exclusive event. Why? Because when you have number 0, 1, 0, 1, 2, you cannot have number 8, 9. On another hand, if you have number 8, 9, you cannot have 0, 1, 2. They are exclusively, mutually exclusive events or disjoint events. And when you have disjoint event, the probability of E or F equal to probability of E plus probability of F. This is true, universal. As long as E and F are disjoint events, you have this formula. And sometimes people use letter A represent event, letter B represent another event. If event A or B are disjoint event, probability of A or B equal to probability of A plus probability of B. Okay, this equation is true only when A and B are disjoint event or mutually exclusive event. Okay, disjoint event. All right. So let's take a look at this example. Addition rule for disjoint events. The probability model to the right, this is the probability model. Shows the distribution of number of rooms in housing units in the United States. Question A, verify that this is a probability model. Means you need to verify 2 items. 1, are each number between 0 and 1? Each number between 0 and 1, yes, they're between 0 and 1. And number 2, if you add all these numbers together, do you get 1? You can verify, yes, you add all these numbers together, you get 1. So that's why it is a probability model. Okay. And question 2, question B, what is the probability a randomly selected housing unit has 2 or 3 rooms? has 2 or 3 rooms. Because a housing unit, when a housing unit has 2 rooms, it cannot have 3 rooms. On another hand, when a housing unit has 3 rooms, it cannot have 2 rooms. Okay? So they are disjoint events. 2 room, 3 room are disjoint. They are mutually exclusive. So probability of 2 room or 3 room, because they are disjoint, equal to probability of 2 room plus probability of 3 rooms. Probability of 2 room 0.032. Probability of 3 room 0.093. You add them together. Okay. So that is the addition rule for disjoint event. Okay. And question C. What is the probability randomly selected housing unit has 1 or more of 3 rooms? There are 3 events here. 1 room, 2 room, 3 room, they're all disjoint. They're all mutually exclusive. So the probability of 1 or 2 or 3 equal to probability of 1 room plus probability of 2 room plus probability of 3 room. The probability of 1 room 0.01, probability of 2 room 0.032, probability of 3 room 0.093. You add them together and you get result 0.135. Okay. So generally speaking, when you have 2 events, E and F, not necessarily disjoint, they're just 2 events. Okay, the probability E or F equal to probability E plus probability F minus probability E and F. That is the general addition rule. And if E and F are disjoint, you don't have this light item here. All right, so now let's look at this example, illustrating the general addition rule. Suppose that a pair of dice, this is a pair of dice, 2 dice are thrown. Let E represent the first die is a 2. Let F represent the sum of the dice is less than or equal to 5. Find the probability E or F using the general addition rule. So let's construct a sample space. When you throw a pair of dice, 2 dice, okay, when you throw them together, the first die is 1. When the first die is 1, the second may be 1. When the first die is 1, the second may be 2. When the first die is 1, the second die may be 3, etc. When the first one is 1, the second may be 4. When the first one is 1, the second one may be 5. When the first one is 1, the second one may be 6. Okay, so you repeat the pattern. This is the first row when the first one is 1. This one starts with when you throw a pair of dice, the first one is 2. So you see here, when the first one is 2, the second one could be 1. The first one is 2. The second one could be 2. The first one is 2. The second one, 3, etc. So you see this pattern, okay? So total how many combinations here, if you count? How many rows? We have 6 rows. How many columns? We have 6 columns. So total we have 36. The sample space have 36 events, okay? And the event E represent the first die is a 2. Event F represent the sum of dice is less than or equal to 5. So the question is, what is probability of E or F? Okay. To calculate the probability E or F, use a general formula. Probability E or F equal to probability E plus probability of F minus probability E and F. So we need to calculate 3 probabilities. So first, what is the probability of E? Okay. E represents the first die is 2. Okay. So all event here represent the first die is 2. All the event here, the first die is 2. You have 6. Okay. Total you have 36. So the probability of E is 6 over 36. 6 over 36. Okay. Next, let's look at the probability of F. F represents the sum of dice is less or equal to 5. Try to use different color. F, the sum of the dice is less or equal to 5. So out of this event, which one? When you throw 2 dice, are the sum equal or less to 5? This one, okay? When you add them together, less than 5. And this one, less than 5, less than 5. This one, equal to 5. And this one, less than 5, less than 5, equal to 5. This one, less than 5, equal to 5. And this one, equal to 5. Do you have other things, other events equal or less than 5? No, it is just the one I circled using the blue color. So you count how many blue circles here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 blue circles, okay? So total you have 36 events here, all over here you have 36. So 10 over 36 is the probability of F. The sum of dice is less or equal to 5. Okay. See, 10 over 36. Okay. And then you have to figure out what is the probability of, use different color. Maybe use, okay, green. E and F, the probability of E and F. So let's see what is E. E represents the first die is 2. F represents the sum of the dice is less or equal to 5. So F is a blue circle I circled. There are 10 of F. 10 events represent F. E is the first die is 2. See, the second row, this is the first dial is 2. First dial is 2. I use red circle. Red circle represents the first dial is 2. So now you want to find the overlap part of blue circle with a red circle. So how many? Only these 3. 1, 2, 3. These 3 events belong to E and F. E represents the first die is 2. F belongs to the sum of die is less or equal to 5. Okay? So it is 3 over 36. Okay. And once you identify those 3 probability, it is an easy job here. Okay, this is the final result. Okay. So that is the general rule for addition. Okay. Last item in this video is a complement of an event. Complement of an event. Let use S represent the sample space of an experiment, and we use capital letter E represent event. The complement of E, we use E then superscript C represent the complement of E. If you use Venn diagram, if this is the event E, anything outside this circle is a EC, complement event. Okay. For example, if you throw a coin, what is the complement event of head? It is tail. What is the complement event of a tail? It is head. Okay. The probability of complement event equal to 1 minus the probability of the event. Okay. Example. Illustrating complement rule. According to American Veterinary Medical Association, 31.6% of American households own a dog. What is the probability that a randomly selected household does not own a dog? So does not own a dog is the complement event of own a dog. They are complement, they are opposite event. So the probability of not own a dog equal to 1 minus the probability of own a dog. The probability own a dog, 31.6%. So 1 minus 31.6%, you get 68.4%. Okay. All right. So that's all for this video. In summary, what we did in this video, again, we did 3 things. First, we talked about the general probability rule, probability table. Remember, there are 2 conditions. Each probability between 0 and 1, add all probability together equal to 1. Okay. We also talked about addition rule for disjoint event, addition rule for general events. Finally, we talked about complement event. Okay. Hope you learned something from this video. Thanks for watching. See you next time.